Hi everyone, welcome to part 2 of Pre-Calculus Chapter 2, Lesson 1, What is a Function? So we're going to take a closer look at evaluating functions for variables this time. So we're starting off at example 4. If you missed the first part of these videos, you would want to review examples 1 through 3 before moving on to example 4. In this example, we're given f of x equals 2x squared plus 3x minus 1. They want us to evaluate for each of the following. So I recommend pausing this video, trying each of these questions, and then hitting play to see if they're right. We're going to take a really close look at letter D. So if you're not sure what D means, definitely hang around for that. For f of a, all I have to do is take the a and put it in everywhere I see an x. There's nothing that needs simplifying, so all I write is 2a squared plus 3a minus 1. For f of negative a, what I would do is take the negative a and put it in. Now negative a squared is a positive a. So I have 2a squared. The negative a would change the sign on this term, so I get minus 3a and then minus 1. F of a plus h does require a little bit more work. The a plus h goes in, and the whole thing is squared. Now, if you're not familiar with the squaring pattern, what you do is you square the first term. So I got a squared. You do 2 times a times h for the middle term. And then you square the last term, h squared. So that's the squared version of a plus h. Now, when I put it in, I have to do 2 times that. So I got 2a squared plus 4ah plus 2h squared. And then don't forget to do 3 times a plus h, which is 3a plus 3h. And don't forget this minus 1 at the end. So I definitely recommend writing it out with the a plus h in here and then simplifying as you go. Now for part D, the final answer comes out to be 4a plus 2h plus 3. I'm going to show you what I did in order to get this. What they're telling me in part D is to take the f of a plus h answer, that was the answer I got in C, and write it down. So this was it right here. And then subtract the f of a answer, which was the answer I got in part A. So I took that and wrote it down right here. And then it's all divided by h. So I just wrote it all divided by h. So I took the answer from part C minus the answer from part A, all divided by h. Now all I have to do is combine like terms on the top, and basically this entire second part should cancel itself out. Nothing should be left of it, but it will cancel out with things from the first part. So the 2a squareds will cancel because it's 2a squared minus 2a squared. And then the 3a minus 3a and 1 minus 1. Okay, sorry, it was negative 1 minus negative 1. To get this, these are my leftover terms. All of them have h's in them. So I'm allowed to reduce by h in each term. Each term is divided by h. So I got 4a plus 2h plus 3 as my final answer. Okay, we're going to be practicing with that more later in our chapter, but it's a good thing to learn now because that is a very, very important process. Our next example is example 5. It says, if an astronaut weighs 130 pounds on the surface of the Earth, then her weight when she is h miles above the Earth is given by the function w of h equals 130 times 3,960 over 3,960 plus h squared. And they want her weight when she is 100 miles above the Earth. So h is the miles above the Earth. So find the weight when she's 100 miles above the Earth. And then what we're going to do is construct a table of values for values from 0 to 500. I recommend counting by 100s. So you would do 0, 100, 200, 300, 400, and 500. So try each of those and then hit play to check your answers. For part A, I would just take the 100 and put it in for the h here. It does come out to be 124, and I did all of that just in my calculator. For the table of values, I did h along the top, w of h here, and I evaluated for each of these values. I just took them and put them in here. The order of operations here, you would do 3,960 plus the value, and then do this 3,960 divided by that answer. You would square it, and then multiply by 130. The next thing we're going to talk about is domain of the function, and that is actually our last topic for this video series. For the domain of a function, now we've talked about this in the past, it's what you're allowed to put in for all of the x values. So you only look for the numbers that the function would be defined on. And for example, if you had like 1 over x, it's undefined when x is 0. So you look for denominators where there are variables, you look for square root symbols, and any other place where you would have something where it's not defined for something. So you always want to be aware of what negative numbers and zeros are doing. You always want to look out for those few things. Often we give our domain in set builder notation or interval notation. However, if you prefer inequalities, you could definitely do that. Just be aware of what your teacher is asking you to do in the directions. So we're going to look at an example where we have to find the domain of 3 different functions. In part A, they give us f of x equals 1 over x squared minus x. Part B, it's the square root of 9 minus x squared. And C, they give us t over the square root of t plus 1. So take a minute, see if you can find the domains for all of those, and then we're going to talk about them. In letter A, I recognized that the x's were in the denominator, so I need to know when that denominator equals 0. And once I find out when that equals 0, I can say that x is not allowed to be those numbers. So I factored my denominator, and I found the zeros. This 0 is 0, and this 0 is 1. And then I said x cannot equal those 2 numbers. In part B, I recognized that the 9 minus x squared is inside a square root. Now you are allowed to do the square root of 0, but you aren't allowed to do the square root of a negative number. So I said that this has to be greater than or equal to 0. And in chapter 1, we learned how to solve an inequality like this. You factor it, you find the zeros, which are 3 and negative 3, and then you use a number line to see when this inequality is going to be true. And I realized that if I put in a 0 and I say 9 minus 0, that is going to be greater than or equal to 0, so the values in between these worked. But if I put in like a 4 or a negative 4, I would get 9 minus 16, which is not greater than or equal to 0, so those didn't work. So this is my final domain for that one. And finally, in part C, I again realized that I have a square root here, but it's also in the denominator. So I knew that t plus 1, the inside of this square root, has to be positive, and it can't equal 0, because if it did, you would be dividing by 0. So all I did was I wrote this inequality, I solved for t by subtracting 1, and then I wrote out my domain that t has to be greater than negative 1. So that's it for this video series. Please let me know if you have any questions.